Here we will discuss full wave rectifier. Uh, we already discussed about half wave rectifier. I'm not going into the detail of half wave rectifier, but here I will discuss full wave rectifier. Full wave rectifier is of two types. One is called central tape. Full wave rectifier. And second one is called full wave bridge rectifier. Here I will concentrate only on this central tape full wave rectifier, while in this video I will not discuss about bridge wave rectifier, but this is another type of full wave rectifier. What is a full wave rectifier? As we know that a half wave rectifier is a device with the help of which we can rectify only the positive half of the output signals. But like if we have a output signal which is of this type, these are the output signal, then in half wave rectifier we only the positive half cycle of the output signal were rectified while the negative signal were blocked. But here in full wave rectifier, central tape full wave rectifier, we can define it as it is a device with the help of which we can rectify both positive and negative half cycle of AC current. This is the diagrammatic representation of full wave rectifier. Here we are using two diodes, while in half wave rectifier there is only one diode. This diode I call it D1 and D2. And we have a transformer, but the transformer is a central tape transformer. The role of this transformer is it can separate this circuit from this output signal, which is 220 volt or 50 hertz. This is one role of the transformer, and the second role is either it step up or step down the output signal. So this is another role. So this is the role of this transformer. So here we are inside. Here the output signals are like this. These are the output signal. This is, let's suppose we have the voltage, and this is the time direction omega t. So this is the positive half cycle and this is negative half cycle. Now this is a central tapes transformer, so the load resistance is connected through a third terminal, which is given here. This is the third terminal. Here we can this is the load resistance, and here we can measure the output voltage V0, while this is the input voltage. Here we can measure the output voltage. Now suppose that the positive half cycle of this input signal reaches to this primary coil, then I call this point as a point A and this point is point B. Here I call this point as C, and I call this point as D, I call this point as E, and this is F. Now if positive half cycle of the input signal reaches to the primary coil, then this point A, or terminal A, become positive and terminal B become negative. Similarly, here we have negative, here this terminal is positive. Now this is diode D1 and this is diode D2. This is the P terminal of the diode, or P side of the diode, and this is the N terminal, or N side of the diode. P terminal is also called anode, and N terminal is also called N part of the C. N side of the diode is also called anode. Cathode, sorry, this is cathode, and P side is called anode. Now if you look at this point A, or terminal A, this is positive, so it means that the P side of the P regions of the this diode D1 is connected to positive terminal and N to the negative. So this diode is forward biased, or it's on. While if you look at here, point terminal B, it's connected to the negative terminal. So it means that the P side of this diode is connected to negative terminal and N side is connected to positive terminal. So this diode D2 is reverse biased, or it's off, means there is no flow of current. Now current, this diode allow the current to pass through it. So current is moving from positive to negative terminal. So the direction of current is here, is this one. So it moves in this way and reaches to point F. Once it reaches to point F, then at point F we have two paths for the flow of current. One path is this FE and the other path is through FC. But if you look at this path, then this diode, which is reverse biased. By reverse bias, I mean is this path is open. It's look like this. We have this, and here we have this. They are not connected, so current cannot flow through this path. So what it means? It means that the current, once reached to point F, it will follow this path and reach to point C again, and then again it goes through the primary coil. So this is the direction of the current. The direction of the current is from A to D, and then to F, and then to C, and then to A. So if I have my output signal, which is this one, okay, these are my input voltage, and this is omega t. This is the maximum value Vm. Then my output signal will be, this is my V naught output signal. V naught, we can measure the voltage here. This is now positive and this is now negative. Here we will connect the voltmeter and we can measure the output voltage here. So here, once this positive half cycle of this input signal reach to this transformer, this primary coil, then D1 become forward bias, it allows current, while D2 is reverse bias, so it does not allow any current. So there is no current. So current direction is this one. So here we have this is the current flowing through the circuit. This is the positive half. This is positive, this is negative, this is positive, this is negative. This is the input voltage and this is the output voltage. So here we know that D1 is on and D2 is off. Or D1 is forward bias and D2 is reverse bias. Now, if negative half cycle of the input voltage reaches to this primary coil of this transformer, then what will happen? If this is positive, this is positive, this is negative. If the negative half cycle reach, then this terminal A become negative and terminal B become positive. While here we have C, which is, this is positive, this is negative. Now again we have the same situation, D, F, E. Now if you look at here, point terminal B is positive. So it means that P side of this diode D2 is connected to positive terminal and N side is connected to negative terminal. So diode D2 is forward bias, it's on. While here the negative terminal is connected to the P sides of this diode D1 and positive to N terminal of this diode D1. So this diode D1 is reverse bias now. So it's off. Before this was forward bias, this was reverse bias. But if the negative output of the signal reaches, then D2 become forward bias and D1 become reverse bias. Now there is no, this is reverse bias, so it does not allow any flow of current through this diode. So this looks like a open circuit now. This looks like open circuit. There is no connection between these 2 points. So there is no flow of current. So the current flow only through D2. This is a short circuit now. Now current flowing from positive to negative. So the direction of current is this one. It flows in this way, passes through this diode and reaches to point F. Once it reaches to point F, then again we have 2 paths. One is FD and the other one is this path. But if current flow through this path, then this path is open. There is no connection between, so there is between these 2 points. So it means that current cannot flow through this path because this is not connected. So it means that the only possible path for the flow of current is through this one, and then again to this way. So the direction of flow of current in this case is from B to E, and then to F, and then to C, and then to B. So here in both these cases, the flow of direction in this load resistance is from right to left. Here it is also from right to left. So it's a unidirectional current. So here once negative half cycle reach, then again the current is rectified. But in this case D1 is off and D2 is on. So by this way, both negative and positive half cycle of the output voltage or output signal is rectified by using this central tape diode. Now if we look at here, then next we have again this positive half cycle of the output voltage. So if this is the positive cycle, then we have again this situation. So here we have again this one. If negative cycle reach to this primary coil of the primary coil of this transformer, then we have this situation. So D2 will allow the current while D1 will block the current. So we have again this situation. The direction of current is same in both these cases. It's from left to right. So it's a unidirectional. But this is not the what we call it a pure DC current. It's a pulsating DC current. And there are both AC and DC component. So this is all about full wave rectifier, how a full wave rectifier work, what is the output if we put a particular types of input. The output is complete. Before the output was only positive half cycle, like in the half wave rectifier. Half wave rectifier allow only positive half cycle while negative half cycle were blocked there. But in this case both positive and negative half cycle were rectified. So this is all about half wave rectifier. Here we have 0, here we have pi, here we have 2 pi, here we have 3 pi, and so on. So this is 0, this is pi, this is 2 pi, this is 3 pi, and this is 4 pi, and so on. In the next video we will discuss about other features of this half wave rectifier, like the output voltage, output current, the average current, average voltage, efficiency, and we will calculate the ripple factor, root mean square value of the current or voltage. All this we will discuss in the next video. Thank you.